Okay, solving equations review. Make sure you watch all of the sections before this, unless you just want to get ahead. So let's start on the left-hand side. Make sure you print off the review sheet first. Let's go with number 1 there. A plus 1 equals 3. Now, we always want to remember that when working on equations, we typically want to work with BEDMAS backwards, so usually doing addition and subtraction before multiplication and division. And here we have a plus 1, and we always want to do the opposite operation to both sides of the equation in the title, solving equations by performing the opposite operation to both sides. So we have a plus sign, plus 1, so I'm going to do the opposite operation to both sides, minus 1, minus 1. Now, on the left-hand side of the equation, meaning the stuff on the left-hand side of the equal sign, we have plus 1, minus 1. We can cross those off. Therefore, A equals 3 minus 1 is 2. Circle our answer. Now, we also make sure that we're going to be checking our answer. Not sometimes, all the time. So we're going to rewrite the equation. We have A plus 1 equals 3. And now we're going to carefully substitute the A value we just figured out back into the equation that we were given with brackets. A is 2, so I'm going to put 2 in for A. Plus 1 equals 3. Those brackets are unnecessary. On the left-hand side, 2 plus 1 is 3. The right-hand side, we have 3. 3 equals 3. Therefore, check mark near my answer. Now, I'm not going to check every single one of the answers on the review page because I do that all throughout each of the different individual sections from this chapter. But I just did it on the first one just as a reminder on the review sheet. So, again, solving equations, performing the opposite operation to both sides. So, let's take A minus 1 equals 2. So this time we have a minus 1. The opposite of minus is plus. So we're going to do the opposite operation to both sides. So we're going to add 1. On the left-hand side of the equation, negative 1 plus 1 is 0. I'm going to cross it off. And A equals 2 plus 1 is 3. Circle our answer. Now I'm just going to actually check my answer in my head. So the equation is above A minus 1 equals 2. Then I'm just going to put 3 in my head in for A. On the left-hand side, substituting 3 in for A, 3 minus 1 equals 2, check mark. Okay, next example, 2A equals 4. So again, solving equations, performing the opposite operation of both sides of the equations. On the left-hand side, we have 2 times A. If you don't see a sign, it's usually times. So 2 times A. So what's the opposite of times? Well, the opposite of times is divide. So divide both sides by the coefficient of the variable. On the left-hand side, 2 over 2 is 1. Cross it off. Therefore, A equals 4. 4 divided by 2, A equals 2. Circle the answer. Now, notice I messed up with the question right where it is. It's difficult to see what the question is to substitute back in, but it did say 2A equals 4. Substituting A back in would be 2 times 2 equals 4. Therefore, check mark. Now, if you have difficulty studying your things, you should be rewriting questions before you do operations. As you can see on the review sheet and all through the notes, I write down the question. I rewrite down the question, do the method. Then I do the next step. Then I do the next step. Now, what I failed to show you was shortcuts. So I'm just going to show you a couple of shortcuts. So back to the first example. You may be wondering how many examples we've done. Well, we've got 3 circles. Therefore, there's been 3 questions. 1, 2, 3. So I'm going to go back up to the top and rewrite the first question. A plus 1 equals 3. There's actually quicker ways that we're going to be doing these things, as you can see all through each individual section of the notes. So if I have a plus 1 on the left-hand side, I can just cross it off, bring it over, and do the opposite sign. A equals 2. Same answer as before, check mark. Okay, this next example, A minus 1 equals 2. We have a minus 1 on the left-hand side, cross it off, bring it over, do the opposite sign, plus 1. A equals 3. Again, same answer, check mark. Be careful with these little tiny steps. They're dangerous. You have to make sure that you know exactly what you're doing. So if you're thinking about the first question, well, we're adding 1. A plus 1 equals 3. Bring it over and do the opposite on the other side. Or what we're actually doing is thinking through, like we explained in the first section, which you're going to be doing soon, is that we're doing the opposite to both sides. It is a It is a scale on both sides. It is a balance of sorts, whereby if we take one off of one side, we have to take one off of the other. If we add one to one side, we have to add one to the other. So make sure you understand the theory on the left-hand side of these notes, and then the little tiny quick methods that we're going to be doing off to the right. So we have 2a equals 4. Now what I can do is I can just cross off this 2, put it down over here, and say a equals 2. That's a very short form of cross multiplication. So let's take a look at the next one. A over 2 equals 3. Now I have a 2 on the bottom, which means on the left-hand side I'm doing divided by, a divided by 2. So I'm dividing. The opposite operation of divide is timesing. I'm going to times those sides by 2. Times 2 times 2. Notice I times the tops. I don't times the bottoms. Timesing the bottom is division. I times the tops because timesing the top is where it belongs. On the left-hand side I have 2 over 2. I can cross them off. And down the page I can say a equals 3 times 2 is 6. Now I can check my answer. The question said a divided by 2 equals 3. I can substitute 6 back in my head for a. 6 divided by 2 is 3. Check mark. Now the quick way for that one is a over 2 equals 3. Now think. Times both sides by 2. Cross off the 2. Put it where it belongs. A equals 6. Just a little bit quicker. Okay, so we just saw a 2 on the bottom and we simply times those sides by 2. Now let's see something a little bit different. 2 over a equals 1. Well, I have an a on the bottom. Now, in the last question, I had a 2 on the bottom, so I simply times those sides by 2. And if you like poetry, it's very simple to learn math. If I have a 2 on the bottom, I times those sides by 2. If I have an a on the bottom, I times those sides by a. Times those sides by a. On the left-hand side, a over a is 1. I can cross it off down the page. 2 equals 1a. Now, 1a is a, so I can circle the answer. Okay, so I'm going to shrink that up. I hope you're not writing as large as I am on your graph paper. So let's take a look at the next example. On the left, working down the page, x squared equals 25. Now, we just took a look at adding, subtracting, multiplication, and division to both sides of the equation. Now we're going to take a look at square rooting both sides. So if I have x squared, the opposite operation is square root. So I can square root both sides, always doing the opposite operation to both sides. On the left-hand side, the answer is x. In the future, we're going to learn why it's the absolute value of x, but we'll do that later. And on the right-hand side, the answer is actually plus or minus 5. X equals plus and minus 5, because 5 squared is 25, and negative 5 brackets around it squared is also 25. Check mark. Okay, working up at the top right, number 7, x plus 4 equals 2x. Now I have a x on both sides. I always want to work on the more complicated side. So the more complicated side is x plus 4, and I simply want to get rid of the x on both sides. You might want to get rid of a number on both sides, but this time we want to get rid of an x on both sides. So I'm going to minus x from both sides. I did that because the answer on the left-hand side, x minus x is 0, cross it off. 4 equals 2 minus x is x. So I could have subtracted 4 from both sides, but then I had to revert and subtract 2x from both sides and eventually divide both sides by negative 1. There's going to be a preference of operations, and you want to decide which one is the best, and we'll get better slowly. Okay, number 8. So we have 3x plus 3x equals 4 plus 8. Now, this is just a reminder question. This is just a make sure that you combine like terms. So on the left-hand side, I have 3x and 3x, so 6x. And on the right-hand side, I have 4 plus 8 is 12. Making sure that you combine like terms on both sides before you start to add and subtract numbers from both sides. So we have a coefficient of the variable. We're doing 6 times x on the left-hand side. The opposite operation is divide, so we're going to divide both sides by 6. And on the left-hand side, 6 divided by 6 is 1. Cross it off. X equals 2. Forgot to check my answer on the last one. X equals 4. Substitute it in. 4 plus 4 is 8. On the left-hand side, we have 8. On the right-hand side, we have 2 times x. X is 4. 2 times 4 is 8. Therefore, 8 equals 8. So check mark on the last question. the one that we just did, x equals 2. We have 3 times x, which is 3 times 2, which is 6. And then again, we have 3 times x, which is 3 times 2, which is 6, which is 6 plus 6, which is 12. And again, the right-hand side is 12, therefore check mark. Okay, let's take a look at 4 open bracket, x minus 3 close bracket equals 8. Now, in the notes, we're going to learn why we could divide both sides by 4, but let's distribute. So I'm going to put an arrow there and an arrow there. 4 times x is 4x. 4 times negative 3 is negative 12. And then on the right-hand side, we have 8. We haven't touched it yet. Now, as you can see in the notes sometimes, I'm going to say dot, dot, dot. The reason why I haven't done the rest of this is because this is the review sheet, where we only do the necessary steps to show you all of the different types of things that we can do in a chapter. So for the example, I could have added 12 and then divided by 4, but I'm not going to. So the next one, we have open bracket, x plus 2, close bracket squared. And we're going to remember that this is x plus 2 all squared. We can't distribute the squared. So this is actually x plus 2 times x plus 2. And for anyone who's doing harder level math in grade 8, who wants to see some grade 9 and grade 10 stuff, we times the first, then the first times the last, then the second times the first, then the second times the last. And x times x is x squared, following the arrows. X times 2 is positive 2x. And positive 2 times x is positive 2x. And 2 times 2 is 4 plus 4. I'm going to shrink my work up a little bit. So that last question is just a step that you might have to do on a certain side in future level math. Dot, dot, dot. Obviously continue, but again, this is a review sheet. So let's take a look at the next one. X over 2 plus 1 over 4 equals 3 over 4. Now you may be saying we have a positive, so we want to subtract that 1/4 from both sides, and you could. This is a review sheet where we're going to teach you higher level stuff. And the method is, if we have a complex or a fraction in an equation, we want to times those sides by the LCD. The LCD is 4, so I'm going to times both sides by 4, timesing everything by 4, all terms. So we're going to times the first term, the second term, and the last term, all the terms by 4. When we times the first term by 4, we get x times 4, which is 4x, divided by 2 is 2x. When we times 1/4 by 4, we get 1, and we times 3/4 by 4, we get 3. Now we have 2x plus 1 equals 3. I'm just going to say dot, dot, dot. I could have subtracted 1 divided by 2, but I'm not going to. And then now we have a over b equals c over d. So in this specific example, what we can do is times both sides by b. Now I could show you that step, b times b, but again, we want to stop doing those elementary calculations. And as we learned above in the example here with the quick method, well, instead of timesing both sides by b, I'm just going to cross off b and put it where it belongs. Again, just cross off b and put it where it belongs. So now a equals c times b over d. Instead of timesing both sides by b, just cross multiplying it up. I could have also cross multiplied d up and crossed off the d and put where the d belonged for full cross multiplication, but you don't have to. And that's the essence. Some people think you have to do stuff in a certain way. No, you just can't break any of the laws. You want to start thinking in that fashion, and it's going to help you do higher level problems. I have a toolbox of things I know how to do and can do. I can make up anything else I can do with any of those combinations. I just can't break any of the laws. So I'm going to shrink those examples up a tad, and the last example on the page is a plus b equals c. A plus b equals c. Now, instead of minusing b from both sides, I'm just going to cross it off and put a minus b over here. Replicating the first example. So some teachers may say stuff like, bring it over. Just be careful if you're going to use that type of terminology. Because if you bring positive something over to the other side, it turns minus. And if you bring minus over to the other side, it turns positive. And if you have times, you bring over to the other side, it turns divide. And if you have divide, you bring over to it turns times. But you really want to make sure you think through the process of the first steps. It's like a balance on both sides, two scales. You have to do the same thing to both sides. And if you can think, add, subtract, multiply, or divide to both sides, and then do the quick method, absolutely. Okay, so that was a review sheet of most of the methods that we're going to see in algebra, doing stuff to both sides, solving equations, performing the opposite operation to both sides, typically working with BEDMAS backwards. But remember, BEDMAS is a preference of operations. To a certain extent, the laws, but it's a preference. But all sorts of times you can manipulate those laws in tiny ways that you don't break them. Okay, solving equations. So again, make sure that you go through all of these individual different steps. And we're going to be doing these algebraic steps all the way until calculus or economics or finance or medicine or law, etc.